Electrostatic painting is the process of charging particles in paint to more efficiently paint a workpiece. Paint, in the form of atomized liquid, is initially projected towards a grounded part using normal painting methods. However, when a powerful electric charge is added to the atomized paint, a significant increase of paint being applied to the part is achieved. Most painting processes refer to this increase as improved transfer efficiency. In more general terms, it means more paint on the part and less paint going to waste. This improvement in transfer efficiency can be measured in several ways. First is the savings in paint cost. If more paint is going on the part, less paint overall is being used in the process. So if paint consumption goes down, the initial cost of purchasing paint will also go down. Second, if less paint is going to waste, then there is less hazardous material to manage after the painting process is completed. Third, if less paint is being used, then lower levels of volatile organic compounds, or VOCs, and hazardous air pollutants, or HAPs, are being emitted, potentially decreasing permitting issues. Fourth, if less VOCs and less HAPs are being emitted when painting with electrostatic technology over conventional methods, it's simply more green, and we all understand the value in that. Okay, so now you're starting to see the benefits of electrostatic painting. But how does it work? Let's go back to your grade school science classes. Do you remember learning about protons, electrons, and neutrons? Remember, all matter contains charged particles. Positively charged particles have more protons than electrons, and negatively charged particles have more electrons than protons. And particles with equal amounts of electrons and protons are neutral. Now here's another jog back in time. Remember playing with magnets? If you take the north poles of two magnets and try to put them together, there's a natural tendency to repel, which is the same result if you try to put the two south poles together. However, if you line up the magnet's north pole to south pole, there's a natural attraction pulling the two magnets together. The same is true for protons, electrons, and neutrons. Like charges repel, and unlike charges attract. So, if we put a powerful electrical charge on atomized paint by passing the paint through a field of electrons and project that paint towards an object that is grounded or has a neutral electrical condition, then we have created a condition that results in a natural electrical attraction between electrons and neutrons, resulting in more paint being applied to the target. Here are a few things to remember when painting with electrostatic applicators. First, if the gun you're painting with gets too close to the part you're painting, the gun and the part become electrically connected, providing a direct ground to the electrostatic gun, resulting in no electrostatic transfer efficiency improvements. Second, if the gun you're painting with is too far away from the part that's being painted, then the charged particles will seek out other closer grounds. Generally, that's the person holding the gun. This tends to get more paint on the operator rather than the part being painted. Third, when trying to paint into corners with electrostatic guns, there is a tendency for the paint to go to the closest ground, which generally does not include deep into the corner. This is known as the Faraday cage effect. When painting into corners with electrostatic guns, it's nice to have the ability to easily reduce or remove the voltage from the gun until this part of the painting process has been completed. Fourth, grounding is an important factor when painting with electrostatics. Keep the part hooks and ground connections clean and free of paint overspray. These connection points play an important part of of setting up the natural attraction of electrons and neutrons. Painting with electrostatics creates opportunity for process improvements in painting operations ranging from automotive, aerospace, general metal, wood, and many other applications where both solvent and waterborne paints are being used. Using electrostatics can increase productivity, reduce paint overspray, and minimize your paint usage. For more information about electrostatic painting and how it can improve your painting process, visit our website at www.graco.com/ProXP or contact your local Graco distributor for a product demonstration.